Hi guys, this is Monica. Today I'm going to show you how to solve kinematics problems. Now, kinematics involves the study of how things move. Today we are going to look at movement that involves constant acceleration. When a body moves from one place to another, the acceleration does not change. It's a fixed value. Now, when you do that, actually, you can have about 5 equations of motion that you can use to help you determine the missing quantities. So these 5 values are displacement, S is for displacement, and the second one here is U. U is the initial velocity in meters per second. That means what is the beginning velocity of the moving body. V is the final velocity in also meters per second. These are all SI units. Acceleration is in meters per second square, and time is taken to be in seconds. So these quantities, there are 5 of them, will result in all these 5 equations. These equations are called the Suvat equations. S-U-V-A-T. Suvat equations or Suvat formulas. Now the first equation is V equals to U plus AT. You can see that in this equation there are 4 quantities, final velocity, initial velocity, acceleration, and time. Similarly, if you take another equation, let's say for example this equation, S equals to ut plus half at square, your S here represents the displacement, U initial velocity, T is the time, A is the acceleration. So again, you have got 4 quantities that are embedded in this equation. So if you know any of these 3 quantities, let's say initial velocity, time, and acceleration, you can find the 4th quantity, which is the displacement. Or if you know displacement, initial velocity, and time, you can find the 4th unknown quantity, which is the acceleration. It's the same for the first equation that we have mentioned earlier. If you know final velocity, initial velocity, and time, you can actually find acceleration here. So in any of these equations that you use, you must be able to determine, or rather you must be given the quantities for 3 values, the values for 3 quantities, so that the 4th quantity can be obtained. Now, let me show you an example to see how we can use these equations in the determination of the 4th quantity. Now, before I do that, I just also want to mention that any physical vertical motion, the acceleration, you can take it as 9.8 meters per second square. This is acceleration due to gravity on Earth. Now, okay, the next thing is, let's look at an example. Now the example reads, a stone is thrown from the top of a building with an initial velocity of 20 meters per second straight upwards. The building is 50 meters high and the stone just misses the edge of the roof on its way down. Now the question is, determine part A, the velocity of the stone just before it hits the ground, and part B, the total time the stone is in the air. Now, when you are given a question of kinematics question of this nature, it will be very helpful for you to draw a very simple diagram. It doesn't take long, but it gives you a visual idea what is going on. Okay, so first of all, we draw the tall building, then we put in the stone, and we know that the stone goes up, all the way to the maximum height, momentarily is stopped there, and then it comes all the way down until it reaches the ground. So other quantities are also given in the stem of this question. So you see that 20 meters per second is given. That's the initial velocity of the stone. It is also given that the building is 50 meters high. So here we go, 50 meters high. Now, how do we start doing the getting the solution? So I would think that the very good habit for you is to make sure that you assign a direction of motion as positive. You can take going up as positive, or if you want, you can take going down as positive, but it does not matter as long as you're consistent throughout in the direction that you have assigned as positive. Now, let's say for today's exercise, let's take going up as positive. So in that way, then we will be able to find out what are the signs for each of these quantities. Now let's find out how to determine the velocity of the stone just before it hits the ground. The diagrams are still there. The tall building, the stone is going up, then it momentarily stays there, and then it comes all the way down and hits the ground. The values are still the same, 20 meters per second. The building, is 50 meters high. So the quantities are all inconsistent with the stem of the question. So the direction in which I assign as positive is going up. So that's important for us to assign the direction in which you take it as positive. Anything that goes up is positive. Anything that is going down will be negative. Displacement up is positive. Displacement down is negative. So the solution is here. So let's list out all the quantities that are given. The initial velocity is plus 20 meters per second. So the question is why it is plus. Now the thing is that the stone was here originally, so when it starts moving, it moves upwards, which is consistent with the direction in which we have assigned as positive. So going up will be positive, so that's why it's plus 20 meters per second. Now we look at the acceleration. Once the stone has been released, it will go up and it will be subjected to an acceleration due to gravity of a value of 9.8 meters per second square. Now, why is it minus, as I said? It's because the pull of gravity is always downwards towards the center of the earth. Irrespective of whether the stone is going up or coming down, the pull of gravity is always downwards, which is inconsistent in the opposite direction to the direction in which we have assigned as positive. So that is why we put it as negative, because acceleration is pointing downwards. Now the last quantity that we know is displacement. So we were originally here. So at the end, the stone was here. So the stone was displaced downwards by 50 meters. So the displacement downwards is minus 50 meters because it is going in the opposite direction. The displacement is downwards, which is in opposite direction to the direction we have assigned as positive. So the signs are very important. They must be stated very clearly in order to get the correct answer. So then the equation of motion that we are using is v squared equals to u squared plus 2as. So you might want to ask, why do we choose this equation? Now you notice that u is given, a is given, s is given, so these three quantities are given. So the fourth quantity can be determined, which is the velocity of the stone just before it touches the ground. So we substitute all the values in, and eventually you get a velocity that is plus minus 37.16 meters per second. Now the question is whether should we take velocity as positive 37.16 or minus 37.16. Well, if you look at the stone down here, just before it touches the ground, it was on its way down, which is in the opposite direction in which we have assigned as positive. So that's why our final answer should be a negative 37 meters per second. Let's look at part B. Now part B wants you to find the total time the stone is in the air. So here again, the diagrams that we have, so it goes up, so you need to find the time that it goes up and the time that goes all the way down. So what is the total time that the stone takes to go up and come down? So quantity is still the same, so direction still the same, going up as positive. So what we have now is to list what is given with the appropriate signs. So initial velocity again is positive, going up is positive. Your final velocity just before it touches the ground here is minus 37. Remember the part A, we've got the final velocity just before the stone touches the ground is minus 37 meters per second, and displacement is minus 50 meters. Initially you are here, so you finally landed up here, so you are displaced downwards by 50 meters. So that's where the minus is in there. So you're given u, v, and s. So then you tell yourself, or you ask yourself, what is the most appropriate formula to use to calculate the time? Well, it turns out that this is the best formula. Why do I choose this formula? Because I know u, I know v, I know s, but I'm going to find t, which is the fourth unknown quantity. The other quantities are all known, the other three quantities. So you substitute the values in, And voila, you've got the answer T as 5.9 seconds, and that would be the total time for the stone to go up and come down, and just before it hits the ground, what is the time interval that the stone has that has elapsed, and it turns out that it's 5.9 seconds. Well, if you find this video useful, please visit my website at www.physicstutionspecialist.com to learn more about how to solve problems involving kinematics, and also to learn how to solve other school physics problems. Thank you for watching. Bye!